This is Sivakumar, 10th Standard Mathematics, Chapter number 1, Continuation of Exercise 1.4. Now, problem number 7. Listen. In each of the following cases, two different subdivisions are there. State whether the function is bijective or not. Justify your answer. You have to give the justification also. First subdivision, a function f from set of all real numbers to set of all real numbers, or capital R refers set of all real numbers, defined by f of x equals 2x plus 1. And second subdivision, a function f from capital R to capital R, defined by f of x equals 3 minus 4x squared. Very important question. Problem number 7. Okay, now subdivision number 1. Solution. First, we can verify whether it is 1-to-1 or not. What do you mean by bijective? Note, for your reference, I write here. Bijective means 1-to-1 and onto. Already I have explained that concept of bijective while I was teaching the definition of bijective. 1-to-1 alone, that is called injective. Onto alone called subjective. Both together is called bijective, remember. Okay, now we can verify one by one whether the function f is 1-to-1, right? For verifying the function f is 1-to-1, we can go for arrow diagram. I do here arrow diagram. Set of all real numbers to real numbers. What about the real numbers? Just listen, note. First, natural numbers, set of all natural numbers, that is represented by the letter n. 1, 2, 3, 4, 5, etc. It is going on. Uncountable numbers are there. Next one is set of all whole numbers. Set of all whole numbers is represented by the letter w. It has 0, 1, 2, 3, 4, 5, 6, 7, 8 going on. It is also uncountable numbers. Next one, set of all integers. Set of all integers, that is represented by the letter z. It has all negative numbers, minus 1, minus 2, minus 3, minus 4, etc. 1, 2, 3, 4, 5, 6, etc. including 0, that is represented by z. Next one, rational numbers of the form p by q. Particularly q is not equal to 0, because if small q is equal to 0, anything by 0 is undefined, infinity, no value at all. The condition q is not equal to 0, remember. So capital Q represents set of all rational numbers. So rational numbers is a superset of natural numbers, whole numbers, integers. So in rational numbers we have natural numbers. Natural number is a rational number, whole number is a rational number, even integers also rational numbers. Next one, irrational numbers. Irrational number is represented by the letter q dash. The complement of q is irrational numbers. Already I have learnt about that irrational number. A number which is having that radical sign. What sign it is? Radical sign. That is a irrational number. At the same time, a non-terminating or non-recurring decimal also irrational number. Non-recurring and non-repeating. I can give some example for you for irrational number. Example, I give one example for you. 0.01 001 0001. Look at that, it is going on. Nothing is repeater, no block at all. 01, here 001, 0001. So it is an example for irrational number. Next one, set of all real numbers. Set of all real numbers is represented by the letter R. Here you are given R to R. Capital R represents set of all real numbers. So real numbers is a superset of all the numbers. What are all the numbers? Natural numbers, whole numbers, integers, rational, irrational. Okay. Now I write here A that is equal to R and B that is also R. A and B represent domain and codomain, both set of real numbers. Okay, so uncountable numbers are there. I take randomly I'm taking 2 or 3 numbers. -3 it is going on, 0 1, sorry, even I can take 2, it is going on. See, even between 0 and 2 uncountable numbers are there. How, sir? 0.1, 0.001, 0.003. So many numbers are there. So that I have put in between 2 numbers, I have put etc. So uncountable numbers are there. Okay. Now, what about f of x? F of x that is equal to 2x plus 1. When x that is equal to -3. X that is equal to -3, I am going to find out f of -3. Substitute x equal to -3 over here. 2 into -3 plus 1. 2 into -3 minus 6 plus 1, that is equal to -5. I take -5 over here. Here -5 is also a real number only. Already I told you -5 is actually an integer. Integer is a real number. Next, when next number I have taken 0. When x equal to 0, find out f of 0. Substitute x equal to 0 over here. 2 into 0 plus 1, that is equal to 2 into 0, 0, 0 plus 1, that is equal to 1. So 0 to 1. That means the image of -3 is -5. Image of 0 is 1. Next random number, what I have taken? 2. When x equals to f of 2, that is equal to, substitute x equals to over here, to x. What is the value of x? 2 plus 1, that is equal to 4 plus 1, that is equal to 5. It is going on, put etc. So 2 has the image 5. Okay, so here also you have to put etc. In between -5 and 1, put etc. 1 over here. Okay, in between 1 and 5, put etc. After 5 also put etc. Okay, look at that. Different elements have different images. Nothing is repeated. -3 has the image -5, 0 has the image 1, and 2 has the image 5. So different elements in the domain have different images in the codomain. Therefore, it is an onto function. F is an onto function. Sorry, one-to-one function. One-to-one function. Since different elements in the domain have different images in the codomain. Okay, so in bijective we have proved only one part, then we have to prove onto, then only we can say that function is in bijective. Then how to put it as an onto? Now for onto, listen, the image of -3 is -5, Preimage of minus 5 is minus 3. Like that. Come on. The image of 0 is 1. Preimage of 1 is 0. Image of 2 is 5 and preimage of 5 is 2. See, for each and every element in the domain must have a preimage in the domain. Once again, each and every element in the codomain must have a preimage in the domain. So that what is given? F of x, that is equal to 2x plus 1. I consider f of x that is equal to y that is equal to 2x plus 1. Already told you f of x and y are same only. So y that is equal to 2x plus 1, which implies y minus 1 that is equal to 2x. I have taken plus 1 to the left hand side, so y minus 1 that is equal to 2x. I am interchanging LHS and RHS. I am writing 2x that is equal to y minus 1. Same only. 2x that is equal to y minus 1. I am going to find the x that is equal to y minus 1 by 2. 2 comes to the denominator. Okay. A that is equal to set of real numbers, even b that is equal to set of real numbers, a function f from a to b. See, for every y there is a pre-image in the domain. For every y, look at the direction. For every y there is a pre-image in the domain, that is x, not x to y to x. So that I am telling there is a pre-image. What about that x, please? X that is equal to y minus 1 by 2. Y to x, that x can be replaced by y minus 1 by 2. See, for example, I take any one number over here. In general, first we write for every y belongs to R in the codomain has a preimage x that is equal to y minus 1 by 2 belongs to R in the domain. Therefore, it is an onto function. For your reference, I take one example you can easily understand. This is full of real numbers. I take any one number. Let minus 5 or minus 4 even can take. Minus 4 belongs to B. B refers codomain. Okay. Therefore, x that is equal to y minus 1 by 2. This is the value of y. Let y that is equal to minus 4. Okay. Substitute x equal to minus 4. Minus 4 minus 1 by 2. That is equal to minus 5 by 2. Minus 5 by 2 actually is a rational number. Rational number is a real number only, no? Minus 5 by 2 is a rational number. Rational number also a real number. That belongs to A. So it is a real number, it is also a real number. So for each and every real number in the codomain must have an image that is in the pre-image in the domain. Therefore, f is an one-to-one and onto function. So together we can say one-to-one and onto means f is a bijective function. Okay, I'll be teaching the second subdivision in the next video. Thank you, children.